to Mr. Thaman Toobunterng from College of Biomedical Engineering, Ransit University. He's gonna talk about the automatic pneumonia screenings from X-ray films for X-ray images using ResNet 50 conventional neural network. All right, so if you ready to present, let's start.
Okay, everyone can see my slide.
Yes, absolutely.
Okay. Good afternoon, everyone. My name is Thaman Toobunterng. I'm a representative of this research. Automatic pneumonia screening from X-ray film by using ResNet 50 convolutional neural network. I'm pleased to be here to talk to you. In my presentation today, I'm going to explain about how our research comes, how can we treat, how can it do, and the future plan of our research. Automatic pneumonia screening from X-ray film is an artificial intelligence which, based on convolutional neural network, has been developed to identify and classify patients with pneumonia, which is primary symptoms of COVID-19. It is an assistant artificial intelligence for medical practitioners and doctors by help in screening and giving a second opinion for diagnosis of doctor. Here is an outline which starts from introduction, object, materials and method, result and discussion, conclusion, and the future plan. First, introduction. I will start with an outbreak of the coronavirus disease. Coronavirus has been firstly reported in Wuhan City, Hubei Province, China, since the late December 2019, and continually evolving, affecting to other parts of the China and other countries. They are giving us a spread effect to almost countries around the world. And this one is a statistics from the WHO, which is the amount of the people who die caused by chronic disease, which less than 3 million people, while the heart disease are around 17.9 million people, and the lung cancer is 1.7 million cancer. But nowadays, there are more than 3 million cases, people around the world who die from coronavirus. What is an effecting of the coronavirus? Effecting of the coronavirus in physiological effect. It is a life-threatening disease causing a high death rate due to the significant alveolar injury and gradual respiration failure. And the global effect, which is then insufficient medical staff. In example, doctors, radiologists, nurses. The resulting delay treatment of an infected patient, this may increase the mortality and widespread of infection. So, how this project can treat? We'll use deep learning to aid the diagnosis to make a decision for the doctor diagnosis these cases, precisely to relieving the problem of misdiagnosis and the problem of the shortage of the doctor diagnosis these cases for better and faster providing of treatments to the patients and taking preventive measures for more quickly. Objective for this research. Our objective is for analyze X-ray images by using artificial neural network to predict X-ray abnormalities and to provide a solution of chest X-ray abnormality for doctor and radiologists, and to develop examination program for patients chest X-ray abnormality. Oops. I'm sorry, I forgot to open my camera. Okay, for the next part is the materials and method. The materials for our research is an chest X-ray film 644 images and the laptop which spec follow this slide with the MATLAB application and the scope of the research. The scope of work was start from the data preparation and then classification, and the last part is testing and analysis. The method that divided into two parts, which is dataset preparation and convolutional neural network architecture. We will start with dataset preparation. Dataset preparation is resized and sorted. After that, we will input the material and label. an image was resized into 224 multiplied by 224 pixels with 3 color channels and sorted by corresponding symptoms name. And after that, we will input their image for neural network training by sorted image with label during the training. And the label will use the folder name that corresponding to an image. This is a flowchart of the data preparation. And now we will talk about the CAN architecture, which is composed of convolution, path, and subsampling. To analyze image pixel will convolved by kernel filter, which is a kernel filter is a metric that moves over the input data perform the dot product with the subregion of input data and get the output as the metric of dot product. The setting dimension of kernel filter will isolate into width, height, and depth. By width, height, and of the image can be set to any square metric size. By the usual set of the kernel convolution operator is a 3 multiplied by 3 matrix, while the depth of the kernel filter will be set at the same as an input. And the second part of the convolutional neural network architecture is an subsampling operator. The user select the size of pooling generally be used in odd numbers. The pooling layer can be responsible for minimizing the data size by excluding or unselect a data which containing no information, which is an blank region, because the blank region do not have the main characteristic that indicate the uniqueness. So we choose max pooling. Here is the deep learning model that we will delve into it. This slide will show the convolutional neural network that we use, while the hidden layer are convolutional neural network that has kernel filter. When the input data was trained, a network will use the filter to convolve any dot on image and pass to max pooling for choosing only region which is not a blank region. Until the fully connected neural network layer, there are the train network step. After we get the trained model, we will use the data with test and check the data for an accuracy. For this diagram, we notice that there will be a convolution which 1 multiplied by 1 shortcut, which is this one, which in the convolution alternating with the identify layer, which is this one, the green one. By the hidden layer help to keep track of the weight loss during the training. This will help the network maintain stable weight. It's affecting to improve quality of the training. In the part of the research and result of and discussion, that is the result of the research. We have employed the RCNN architecture described in the earlier section and train it with the RCNN to classify the two types, which is no finding and pneumonia. And we also comparison between the proposed from AI and medical doctor. From this one, you will see the result from the AI, which is pneumonia confirmed 99%, and from the doctor is COVID pneumonia. This one is no finding and confirmed by the doctor, which is no finding. And this one is pneumonia confirmed 99%, which is pneumonia. But this one, you will see that it have some error from this one. Sorry. In this state, AI will tell which is no finding confirmed 69%, but an actual is pneumonia, which this missing is caused by false positive. For the confusion metric, you will see the confusion metric result, which is shown is and 100%, but the actual result is 99.66% is caused by the program estimate the value, which is nearly 100 to be 100%. The false positive is caused by had a similar probability on the both categories, such as no finding and pneumonia, of 58% and 42% respectively. So this could lead to the false positive decision of the proposed AI, but there are only 0.34% of the result from training. But the overall accuracy is more than 99%. This proposed AI can serve as a second opinion for medical diagnosis and hopefully can serve as a provisional screen tool to reduce the heavy burden on the medical. For the conclusion, this paper describes a CNN architecture can be used to classify X-ray films to identify pneumonia disease, which is strongly related to COVID-19, and the accuracy is 99.66%, which is 0.34% is false positive. Although the trained network has achieved acceptable accuracy, the number of datasets is trained was limited because of the training with only 644 images for the pneumonia case and normal case. In the current state, we cannot further classify between conventional pneumonia, as you see in the result, like this one. We cannot classify between conventional pneumonia and COVID-19 due to the insufficient chest X-ray film from COVID-19 patients. But in the future plan, we will increase an accuracy by decreasing the false positive, and we will classify COVID-19 from the conventional pneumonia. Both of these solutions will be done by collaborating with hospital and relevant sections to combat an outcome of the harmful virus as soon as possible. Thank you for your attention.
Right, time to questions. If there's any questions for audience or chairman? All right. Okay, everyone's too quiet. So, yes, we have questions. Okay, from the chat room. You can see in the chat rooms. The first one is about the F18 and F20.
Maybe number F18 and number F20. I see on your proceeding talk about the finding of the AI. I think it's mismatch between AI and medical doctor said. In this picture you didn't show it. No worries. I asked you what is the cause why AI say is normal. It might be in your proceeding pictures. Do you have number F18 image and F20?
F18 and F20 there is on your paper, but I didn't show that on.
No worries, no worries.
I'm sorry.
What do you think about the cause of the mismatch between AI and medic said? Because medic said it's pneumonia and the general appearance is quite pneumonia because you can see the white color fill in the lung lobe.
The cause that AI and doctor has mismatch of the result is there is some false positive that AI process is and something like 58%, and which is in example AI said it is no finding 58%, but and they said the pneumonia is 42%. So this one is nearly result. So the AI may process the wrong, like a false positive. But if we have the more sample case, like more famous array, there will give the knowledge for AI, and then it may be more accuracy and decrease the false positive.
All right, thank you.
Thank you. And next question.
Next question is about the percent of accuracy up to 99.66%. So it's too good. So what is with the training gradations or tests? You can choose for the tests and gradations. I'll show from the paper.
Okay. The trend.
Can I answer this question because I am author of this paper also. Hello everyone, I am Chita Pratana Sumokun. And for this question, we use accuracy or validation sets. We use a validation data set to trace. And after that, we got this accuracy. And from the second question, what did you use the train voltages for? Okay, well, we use train sets for just training network that they can recognize this image that is it normal, abnormal, and abnormal we provide that is no finding. And for the pneumonia case or COVID-19 case, we provide it is like pneumonia. And for validation data set, we random use chest X-ray images from normal, abnormal, and from pneumonia also for validation. But we also know which one is normal or which one is abnormality. And for the tests, we randomly we don't know anything about them, but we know that it's a mix from many sources, and we use it for test. And for the third question, there are any limitation associated with resizing? Yes, there are limits. That's because we use less than 50 for train. So we have to resizing the images to 2024 because the input size is required 2024. Thank you.
All right. So usually validations is used for model tuning. And what is your opinion? The questions more in the chat room. Please turn on your microphone.
Yes,
Okay.
it's using for model tuning, and for the data cases we have limit in this paper because the COVID-19. Actually, in this paper we aim to use for recognize for pneumonia, and in this paper we use only 6,064 images, and we cannot find more than images for data tested, so we can use for only validation sets only. So we use the accuracy this to show that our model is accuracy is 99%. And after that, we can find more images for the next project, and we can find more allow 1,020. Oh no, sorry, 100,000 images for train, but we didn't show in this paper. Thank you.
Okay, thank you so much.
Okay, thank you, Dr. James, for questions. And any questions here? Okay, so all right. Okay, it's a time to move to another presenters. Thank you, Ajahn Rachid. So the next presenters. Okay, thank you for our presenters. Thaman, Mr. Thaman. Okay, he did the best. And thank you, Ms. Thitapha, to answer your questions. So the next presenter.